on the electrodynamics of moving bodies. It is known that Maxwell's electrodynamics are usually understood at the present time when applied to moving bodies leads to asymmetries which do not appear to be inherent in the phenomena. Take for example the reciprocal electrodynamics action of a magnet and a conductor. The observable phenomenon here depends only on the relative motion of the conductor and the magnet. Whereas the customary view draws a sharp distinction between the two cases. In which either the one or the other of these bodies is in motion. For if the magnet is in motion and the conductor at rest, there arises in the neighborhood of the magnet an electric field with a certain definite energy. Producing a current at the places where parts of the conductor are situated. But if the magnet is stationary and the conductor in motion, no electric field arises in the neighborhood of the magnet. In the conductor, however, we find an electromotive force, to which in itself there is no corresponding energy. But which gives us a rise, assuming equality of relative motion in the two cases discussed, to electric currents. Of the same path and intensity as those produced by electric forces in the former case. Examples of this are, together with unsuccessful attempts to discover any motion of the Earth relatively to the light medium, suggest that the phenomena of electrodynamics, as well as of mechanics, possess no properties corresponding to the idea of absolute rest. They suggest rather that, as has already been shown to the first order of small quantities, the same laws of electrodynamics and optics will be valid for all frames of reference for which the questions of mechanics hold good. We will raise this conjecture the purpose of which will hereafter be called the principle of relativity. To the status of postulates, and also introduce another postulate, which is only apparently irreconcilable with the former, namely, that light is always propagated in empty space with a definite velocity c. Which is independent of the state of motion of the emitting body. These two postulates suffice for the attainment of a simple and consistent theory of the electrodynamics of moving bodies based on Maxwell's theory for stationary bodies. The introduction of a luminiferous ether will prove to be superfluous inasmuch as the view here to be developed will not require an absolute stationary space provided with special properties, nor assign a velocity vector to a point of the empty space in which electromagnetic processes take place.